When working with LLMs, one of the biggest challenges is getting consistent, structured responses. If you're extracting data from AI-generated text, inconsistencies can make automation difficult. In this video, I'll show you what it looks like when you try working with unstructured outputs. I'll then show you how to use Pydantic to make the LLM produce structured, consistent responses. In this example, we will be providing the LLM with an HTML table, and we will ask it to extract the data into a schema that we can programmatically use. In this tutorial, we'll be using Ollama for the LLM. If you don't have Ollama installed, check out my AI Engineering for Beginners video, where I show you how to install Ollama. If you've got Ollama all set up, let's get started. Okay, first thing you should do is set up a project, like so, and have an app.py. I've gone ahead and created my own HTML table, and you can create something similar. It doesn't matter how exactly it should look. The only thing that does matter is that you do have a name, birth year, and then birth country, as this is what we're going to be trying to extract from the table. But before we get started with programming, we should first set up our Python environment. So we will get a terminal within our VS Code ready. We will type python -m venv and call the virtual environment venv. With that virtual environment set up, we now need to enter it by going into venv scripts activate, and you know this will work when you see this venv at the beginning of your path. There are two packages which we'll be installing, first being Ollama and the second Pydantic. So what we need to do is pip install Ollama and Pydantic. Okay, so that's all installed. So to begin with, the only thing we will import is Ollama, as I'm going to show you what it looks like when you try to extract information from an HTML table, but you don't have your prompt fully set up for structured outputs. So we have imported Ollama. We are next going to start writing a prompt, and this will be, we'll do formatted string, and we'll do 3 quotes, so it's a multi-line string, and let's write this as, I want you to extract the name, year, and country of every person in the following HTML table. So we've done that, and now we will place the HTML table inside of the prompt. So that is a very basic prompt, and now we just need to pass it to an LLM. Before we do, the LLM that I like to use is Llama 3.2 and 1 billion parameters. So if you don't have that installed, go to the terminal below and do Ollama pull Llama 3.2 :1b. So that will download the Llama 3.2 1 billion parameter model for you. I've already got it installed, so it's done instantly. So we will now pass this prompt to this LLM, and we'll do that by response is equal to ollama.chat. We will specify the model as being Llama 3.2 :1b, and then we need to set up the messages being sent to it. So messages is equal to list. Then the first message will be role of user, which is us, and then the content of a message will be the prompt. Once this is run, the message in response from the LLM will be in our response variable. Then we can go print response message, then content. I think that's all that we need to do to have it run initially. So let's give it a try by doing python app.py. Okay, so it's finished, and this is how it's formatted it. So the response it gave us is, here are the extracted information for every person in the HTML table. It's given full name, and it's gone John Doe, and the name John Doe, Jane Doe, and so on. Then it's done John Doe, the year, Jane Doe, the year, and so on, and birth country, John Doe, country, Jane Doe, so on. So that is the format that it decided to create for us. But if we were to write code on this, we won't be able to consistently use it. Firstly, it's got this text at the top here, so we would have to filter out that text. Next, we would have to manually go through and write code which filters out the full name here, filters out this section, and just grabs what's in the brackets. But then we would need to tie it all together by using this as a key or something, and it's even doing different formats where it's got the square brackets here, then no square brackets here. And something that I am going to do is rerun it to see whether it actually gives us this same format, or maybe it chooses a different one. So let's wait and see. Yep, this time it has given us a completely different format entirely. It's created its own table with ASCII formatting, and it has text at the top here. It's now got text at the bottom here. So basically, the current prompt we have is unusable if we want to have reproducible outputs. So that's where Pydantic comes into play. So with Pydantic, you can create Python classes or models, and you can specify normal class structures where you've got a property and using typing to specify the type of it, but then you can also use fields from Pydantic, which allows you to provide a description as to what that property is. And then with these Pydantic models built, you can embed the schema of it into the prompt, and it will allow you to have the LLM produce more consistent outputs. So we will get started with that. There are a few things we need to import. Firstly, we will do from typing import list, because the plan is to have a people list which contains a list of person. That's how we're going to set this up. So now from Pydantic, we will import the base model, which is going to be used for the classes, and then field, which is going to be used for the properties of the class. And we are also going to import JSON, because with Pydantic we can create model instances by importing JSON into it. Then we can also turn the models into JSON itself. And so JSON is what we're going to be having the LLM produce in its output. So we have this all set up. Let's go and create the classes. So we're going to start off with a class called person, and this is going to use base model. We are going to have 3 properties. First being name string, second being year int, and the third being country string. So like I said before, we can use the field on our properties to provide descriptions for them. So we can do name is equal to field. First thing we do is 3 dots, which is basically just a default value set for it. And then we provide a description of, so go here, description, and we can do the name of the person. Now we can do the same thing for each of these properties. This will be, say, the year the person was born, and then the country can be the country of the person. So we now have Pydantic model for an individual person, but we're trying to extract all the people from it. So we now need to create a Pydantic model for the list of people. So we'll do class people. We'll make this base model, and what we'll do is we'll create a property called people. This will have a type of list person, and same thing again using the field. This will be the list of people. So we have that set up, and what we can now do is embed the schema of these people into the prompt. So let's go down to where our prompt is. So I want you to extract the name, year, and country of every person in the following HTML table. To better format things, we're going to use XML tags to enclose the information that we're using. So let's do HTML table. Actually, we'll just call this HTML because the table itself has a table like that. And now we'll do, I want you to output this list of people using the following Pydantic schema. So let's do schema, and we'll add the closing one. And for this, what we need to do, curly braces to add it in, people, and it'll be dot model underscore JSON underscore schema. So let's leave it as it is for the time being, but let's see what the output it gives now. Okay, so it's not quite there yet. It's given us a long list of stuff. So it's giving us instructions for how to use Python to extract the information. Although right here it's created that list, but it's not giving us it in the correct format. So there is some more prompt engineering that we need to do to make this LLM give us the output that we want. So let's see what else we can do. Let's change this initial prompt, and let's do extract every row from the following HTML table and convert it into a structured JSON object following the schema below. So we've added that in. We've got our HTML table and we have this. So let's remove this because we've specified that we've got the schema below, and let's run that to see if that makes any improvement. Okay, let's take a look at this output. This seems to be correct. Let's see, Emma Taylor 1992 Spain. It's got it all in the correct format, although it's still got a bunch of extra stuff that's including with it. So it's giving instructions for how you would actually do it. So it's still including stuff that we don't want along with it. And interestingly, it gave us JavaScript code with it, but we can see it's capable of giving it to us in the correct output, but it's not fully doing it. So we still need to add more to our prompt to make it give us the desired output that we want. So how about we give it some more instructions? So let's think about what things we want from this. The first thing we want for it to extract every person from the table above. That's the first thing we want to do. We want it to generate a valid JSON object that matches the schema above. We want it to return only JSON with no additional text, markdown, or explanations, and maybe that's enough instructions for now. So let's see if this improves the output. Okay, so it's given us response, and it's very close to being there. Hasn't given us exactly the schema because it needs to be an object which has key of a people, and then this is inside of it, and then it's also included these backticks, or whatever they're called, within it. So it's Not quite there yet. We'll add some more instructions. Let's say do not include 3 backticks or / JSON in your response. So these backticks are used for code blocks within Markdown, which is why it has been commonly using that throughout. So we see here it's got tick 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 JSON. So hopefully that is enough for our prompt to make it not do that. So let's try it again. Okay, well this one is starting to get worse. It's now given us our schema as the JSON. So maybe to counteract this happening, we need to give it an example as to what the output should look like. So to do that, I'm gonna minimize this just so we don't have this constantly here. Let's create example people, and we're gonna make this people, and this contains a list. So let's go in here and do person, list name equals person name, year, we'll just make this 2000, and country equals person country. And let's just duplicate this several times. So we've now got our people, which has a list of people within it, and what we can do is also add this to the prompt. So let's do example, and we'll do example like so, and this is going to be a similar thing where it'll be .model dump underscore JSON. So I've now got an example as to what it should look like within the prompt, and hopefully that will make it produce an output that we want. So maybe this time when we run it, it will work as we hope. Oops, I made a mistake here. Example people, this should be people is equal to this. Now it should work. Okay, that is not what we wanted. It's now using this as the information for it. So that means we need to add some more stuff to our prompt. Maybe we'll do the following is an example of what the JSON output should look like. And is there anything else we should add to instructions? Let's add an instruction. Your output, let's make this capital. Your output should be structured exactly like the example, but with different and real values. So hopefully it knows, okay, the way that the JSON from this looks is what it should look like, but it should now hopefully know not to use that and use the data from the table to create the JSON. So let's see if that's worked. Okay, that looks correct. People, let's go to the table, which I hid here. John Doe, 1990, USA. Jane Doe, 1995, UK. Michael Smith. That is looking to be correct, although it didn't include these 2 people, which is not what it should have done. So maybe there is more we can add to the prompt. Okay, you need to rewrite this part. So let's say extract every person from the table, and maybe generate a valid JSON object that matches schema above and uses all the people extracted from the table. Let's try that and see what it looks like now. Okay, that looks to be more like it. Let's see, 1, 2, 3, 4, 5, 6, 7. I think there's 7. 1, 2, 3, 4, 5, 6, 7. Okay, it's now starting to look correct. So now that we've got the LLM giving us proper structured output, we can now use this response and programmatically use it. So to do that, we've got our response here. Let's do, we'll keep that printed, but we'll do response text is equal to this, just so we've now got a variable. Actually, we'll call it response string because that's what it is. Now we'll do response JSON is equal to JSON.loads response string. So if it works correctly, this should now be a dictionary containing all the data that was in the prompt. And now we can create our people object of the model. So people is equal to people, and then we use our response JSON data within it. And then with this, we should be able to do for person in people.people, we can print person. So hopefully it's now all going to work. And as we can see here, each of the persons within people.people is now being printed out. Or in other words, we have now made the LLM do what we want and present us with information in a structured format, which allows us to programmatically work with it. When working with LLMs and developing AI augmented applications, you need to be able to have a way to have the LLM produce consistently structured outputs, so then you can go in and programmatically use it throughout your applications. Using Pydantic, we've been able to solve this, and we were able to have the LLM extract people from HTML table and then turn it into a structured output, which we can now programmatically use. If you like this video, make sure to like and subscribe.